In this lesson, we're going to be factoring ax squared plus bx plus c and using factoring to solve real-life problems. In section 7.5, you factored polynomials of the form ax squared plus bx plus c, where a equals 1. First, look for the greatest common factor of the terms of the polynomial, and then factor further if possible. For example 1, we want to factor 5x squared plus 15x plus 10. And the first thing we always want to see is, can I factor out a GCF, greatest common factor, that will make this x squared value 1? And even if I can't do that, it's going to make my life easier to factor out the greatest common factor. Here, this is a 5, a 15, and a 10, and I can factor out a 5 here from all of these. So I'm just going to rewrite this as 5 times x squared plus 3x plus 2. Okay, so now I have this 5 out here. And then this x squared plus 3x plus 2, well, we just factored stuff like this in the last section, so let's factor this. Okay, so my b value is 3, my c value is 2, so I need two numbers that are going to multiply to 2 and add to 3. Well, that's just going to be 1 and 2. Those are the only two options, okay? So I can rewrite this as x plus 1 times x plus 2. Then I bring down the 5, and if I multiply this whole thing out, I'm going to get 5x squared plus 15x plus 10. And you can try that on your own if you'd like. But anyway, now we're done with example 1. So right now, I'm going to multiply mx plus p, that quantity, times the quantity nx plus q to introduce our next method of factoring here. Okay, so if I FOIL this out, I get mx times nx, which is mnx squared. And then I do mx plus q. Well, that's mqx, positive, of course. And then if I do p times nx, that is plus npx. And then p times q, well, it's just going to be plus pq. Okay. Well, notice I have two x terms here, and I can rewrite this as mq plus np all times x. All it is I factored out an x from this mqx and this npx. Okay. Then I'm just going to rewrite the rest of this. So I get mnx squared plus this mq plus np quantity times x plus pq. Okay. Well, if you remember at the beginning of the lesson, what we're going to factor is polynomials of the form ax squared plus bx plus c. Okay. And if you notice, I have an x squared here, an x squared here. I have a b here and an mq plus np. And then I have a c and a pq. So I'm going to write that out here. So I can see that a is going to equal mn, b is going to equal mq plus np, and then c is going to equal pq. And notice, c equals pq, that's the same as our method in 7.5. Okay. Anyway, if you notice, if I multiply a and c, I'm going to get ac equals mn pq. Okay. So the product of a and c actually tells me all of the factors that are going to be in here. And I can also use my b value, which is mq plus np, to help me when I'm factoring something in this form. Okay, so what I'm going to do now is take this entire expression right here, mnx squared plus quantity mq plus np, all times x, and then plus pq, and then go backwards and factor this using a method called grouping. Okay, so if I go over here, I'm going to rewrite this out. I have mnx squared plus parentheses mq plus np x plus pq. Okay, now if I just distribute this x, I'm going to get mnx squared plus mqx plus npx plus pq. Okay, I'm going to zoom in here. Okay, and then what I'm going to be doing is factoring by grouping, like I said, and I'm going to separate these two things into groups. So I have this group, and then I have this group. And I just want to factor out what I can. Well, here I have an m here and an m here, and I have an x squared and an x. So I can factor out an mx. So if I rewrite this as mx times, and then I have what's left here is just going to be nx, and then what's left here is just going to be q. So this is going to be nx plus q in parentheses. And then plus, well, what I can factor out here is a p. Okay, this is going to be a p right here. So times p. And then over here, what's left is nx. And then plus, well, if I factor a p out, I just have q. Notice that here I have nx plus q, and then here I have nx plus q. Well, I can use the reverse distributive property to rewrite this whole thing as, I'll use black right now, mx plus p times nx plus q. Okay? So all I did was I started with this expression, kind of confusing. Okay, I distributed this, then I grouped these. I put these into their two groups, factored out the greatest common factor, okay, and I ended up with some number times x plus a constant times some other number times x plus another constant. Okay, and this would be the fully factored form. Okay, so this might be confusing, and hopefully it will make a lot more sense once we go over our first example. So for example 2, we're going to factor each polynomial, okay, and I'm going to zoom in on part A right now. I have 4x squared plus 13x plus 3. Okay. Well, if you remember what I just showed you, if I multiply my a value and my c value, that's going to be the same thing as all the numbers that I need multiplied together. Okay. So my ac value is very important here. That's going to be 12 because 4 times 3 is 12. Okay. And the b value is also very important because what we're going to end up doing is we're going to split this 13x up into two things that we can end up factoring by grouping here. Okay. So I want to write down my b value as well, 13. Okay. And what's going to work out, kind of like what we did when our a value was 1 or there was no coefficient on our x squared term, we want to find two numbers that multiply to 12, this ac here, and then add to 13. Well, if I write down my factor list for 12, I'm going to get 1 and 12, 2 and 6, and 3 and 4. So these all multiply to 12, but I want to see which one of these add to 13. Well, that's just going to be 1 and 12 here. So what I'm going to do is I'm going to break up this 13 into 1 and 12. I'm going to break up this 13x into 1x, or just x, plus 12x. Okay, so this is going to be broken up into 4x squared plus 12x plus x plus 3. Now, it does not matter what order you put this in. I could have put the x first and the 12x second. It would have worked out either way. Okay. Now, I want to use my groups. I want to make my groups. I'm going to do my first two terms in one group and my second two terms in my other group. So I'll do like this. Okay. So now what I want to do with each group is factor out the greatest common factor. So here I have a 4 and a 12, so I can factor out a 4, and I have an x squared and an x, so I can factor out an x. So I'm going to get 4x times what's left inside the parentheses is just going to be x plus 3. And then over here, I have x plus 3. I can't factor anything out here. So if I can't factor anything out, what I want to do is write 1 just to make my life easier. So if I do plus 1, and then times my x plus 3. Notice that I have 4x being multiplied by x plus 3 and a 1 being multiplied by x plus 3. And I can use the reverse distributive property to rewrite this as 4x plus 1 times x plus 3. Because if you think of this, if you distributed this x plus 3 to this expression right here, you'd do x plus 3 times 4x and then x plus 3 times 1. Okay, so now we have successfully factored this using grouping. There are other methods to factor this, but I personally think factoring by grouping is the easiest way to do this. Anyway, now we're done with part A. I'm going to go over to part B right now. So the first thing we always want to do is write down our AC value. AC, in this case, is going to be 3 times 2, which is 6. And then B is going to equal -7. So I want two numbers that are going to multiply to 6 and add to -7. Well, if I make my factor table, I have 1 and 6. I have 2 and 3. And that is it. Now notice my b value is negative and my AC value is positive. That means I want two numbers that are going to multiply to be a positive number, but add to be a negative number. So both of the numbers are going to have to be negative. Okay? And I can see if I make both the numbers negative here, that -1 plus -6 equals my -7. -2 plus -3 does not. So these are my two values. And remember, we take these values, right? And all we're doing is breaking up our b term. Okay, so instead of writing -7x, we're going to write the exact same thing as -7x. We're going to have -1x, or just -x, and a -6x there. So I'm going to rewrite this. So I have 3x squared. And remember, all I'm doing is breaking up this b term. So minus x and then minus 6x. Okay, the -1 goes to the minus x, the -6 goes to the minus 6x. And then I have this plus 2. I'll just bring this down. And once again, the order doesn't matter here. You could have put the -6 first or the -x. It would work either way. Okay, now I'm going to do my groups. So I have this group. And then whenever you have a negative, I'd recommend changing this to plus the negative instead of the minus, just because it's going to make it easier. So I'm going to do plus -6, x plus 2. Okay, now I'm going to factor out my greatest common factor. So here I have a 3x squared, and here I have a minus x. So all I can factor out is an x. So I have x times 3x, and then minus 1. And then here I have a -6x and a 2. Now, we can factor out a 2, but I would actually recommend factoring out a -2 because we want this thing to be the exact same for both. Okay, we want this 3x minus 1 to show up over here. And if I factor out just a +2, I'm going to get -3x plus 1. Okay, then I have to factor out a negative. So I'm going to factor out a -2. So I get -2 times, and then what's left here is 3x. And then what's here is going to be -1. Okay, and if you're not sure, you can just distribute it and see if you get the same thing. Anyway, now since I have the same thing being multiplied here, and here I can rewrite this as x minus 2 times 3x minus 1. Okay, and now I've successfully factored our expression in part B. And once again, you can FOIL this out to see if you get our original polynomial, and I'll let you try that if you want to. But anyway, now we're done with part B. For example 3, we're going to factor 2x squared minus 5x minus 7. Okay, like always, we want to write down our AC value, the product of A and C, because that contains all the numbers we need, and then our B value. Okay, well, our B value is -5, and our AC product is going to be 2 times -7, so that's going to be -14. I'm going to zoom in a little bit. Notice that my product is going to be negative, which means I'm going to have one negative number and one positive number. Okay, and then notice that they're going to add to a negative number, which means that the absolute value of the negative number is going to be larger than the absolute value of the positive number. But we'll get to that in a moment. Okay, so now I want to write down my factor pairs, and I'm going to ignore the signs at first. So my factor pairs are going to be 1 and 14, and then 2 and 7. Now I'm going to think about the negatives. Like I said, because I have a negative product and a negative sum, the larger absolute value is going to have the negative sign. So this is going to be -14 and -7. Okay, and then if I add them up, -7 plus 2 is -5. So this is going to be my pair here. -14 plus 1 is -13. So all I'm going to be doing is breaking up this -5x. I'm just going to rewrite -5x as +2x and -7x. Once again, the order doesn't matter. So I'm going to rewrite this as 2x squared, and then breaking up this -5x, I have my 2 and my -7 as my coefficient, so plus 2x minus 7x, and then minus 7. All right, now I'm going to make my groups. So I'll put a group here, and then since I have a minus sign, I'm going to do plus the negative. Okay, so now I have my two groups, and I'm going to factor out the greatest common factor. So I have a 2x squared here, and I have a 2x, so I can factor out a 2x, and then times just x, plus, well, if I factor out the entire 2x, all I'm left with is 1. So I have a 1 here. And then over here, I want to factor out my greatest common factor. Well, I could factor out a +7, but once again, I see that there's a negative and a negative here, and I want this to become x plus 1. So I'm going to factor out a -7. So it'll be -7 times, and then +x plus 1. All right. Last step, I'm just going to rewrite this as 2x minus 7 all times the quantity x plus 1. So 2x minus 7 times x plus 1. All All right, and now I've successfully factored this one. Once again, you can FOIL this to check to see if you get your original value, and I'll let you do that on your own if you want. But now we're done. So for example 4, we're going to factor negative 4x squared minus 8x plus 5. And notice we have a negative coefficient of a. Now, there's a couple things you can do. You can either rewrite this as negative parentheses positive 4x plus 8x minus 5. All I did is factored out a negative here. Or you could just do it normally. I'm just going to do it normally, but no, you can always do it this way. Okay. So the first thing I'm going to do is always write out my AC and B value, and I'm actually just going to rewrite our normal expression, 4x squared minus 8x plus 5, and then here's AC. Well, negative 4 times positive 5 is negative 20. My B value is negative 8. So I'll zoom up here. And note, I have two negative numbers again. So when I write my factor pairs, it's going to be 1 and 20, 2 and 10, and 4 and 5. Okay? Now, if we look back at the signs, they need to add up to a negative number and multiply to a negative number. So since they're going to multiply and add to a negative, I need numbers with different signs, and I need the larger absolute value number to be negative. Okay? So I'm going to put my negatives in my larger numbers. Well, if I add these, I get negative 20 plus 1, that's negative 19. That's not going to work. If I do negative 10 plus 2, that is going to work. That's going to give me negative 8, and then negative 5 plus 4 will not work. So I have negative 2 minus 10. Okay, so same thing as always. I'm going to rewrite this b term, negative 8x, as positive 2x minus 10x. So I'll just write negative 4x squared plus 2x minus 10x plus 5. Okay, now I'm going to make my groups. So I have a group here, and then I'll do plus the negative in my group here. And then what I'm going to do is factor out a negative 2x. So this is going to be negative 2x. Okay? And then if I factor out a negative 2x, that's fine. I can just put a 2x here. This will be 2x. And then since I factored out a negative 2x, this is going to turn into negative 1. Okay? And since I factored out a negative here, and I see a negative here, and I want this inside to be positive, I'm going to factor out a negative 5 here. So this is going to be negative 5. And then I'm going to have 2x, and then minus 1 again. Okay. Now what I'm going to do is I'm going to rewrite this as negative 2x minus 5 in parentheses, and then 2x minus 1. Okay. Now this is fine, but often you'll see people take these two negatives and factor it out and just put it on the outside. Okay, so you could rewrite this as negative quantity 2x plus 5, and then times 2x minus 1. Both will work in this case. Anyway, we've successfully factored this one, and now we're done. For example 5, the length of a rectangular game reserve is 1 mile longer than twice the width. The area of the reserve is 55 square miles. What is the width of the reserve? Anyway, we know the area of a rectangle is area equals length times width. And if we look right here, we know that the length is 1 mile longer than twice the width. So we can write an equation with that. So that's going to be the length is equal to 1 mile more, so it's going to be 1 plus or something plus, and then twice the width. Well, that's 2w. Okay, so you can either write 1 plus 2w, or you can write L equals 2w plus 1. Anyway, to answer this question, I'm actually going to use substitution to plug this length in here. Okay, and I also have the area of the entire rectangle, which is going to be 55 square miles. So I can plug this in for A. So if I take this and plug this in for A, and then I take this and plug this in for L, I can rewrite this and then solve that equation. So I'm going to zoom in. So now I'm going to get 55 equals, my new length is going to be 2w plus 1 in parentheses times w. Okay. And then now what I can do is just distribute this w to simplify. So I'm going to get 2w squared plus w equals 55. Now to solve these types of equations, we want to end up using the zero product property. Okay? So the first thing I'm going to need to do is get rid of this positive 55 by subtracting it on both sides. And rewrite this as 0 equals 2w squared plus w minus 55. All right? And then what I can do here is just factor this expression and then find my w values. So notice my b value is 1, and my ac value, well, 2 times negative 55 is going to give me ac equals negative 110. All right? And you could list out all of your factor pairs of negative 110, or you could just try to find a value that works, that might be quicker. Okay? And that's what I'm going to do here. Well, I know that 11 times 10 is 110, and I see that the difference between these is 1, okay? And I see that this is a negative sign. So the negative sign means that they're going to have two different signs, so it's either going to be negative 11 and positive 10, or positive 11 and negative 10. And since b is positive, that means when I add them, it's going to be positive. So if I do 11 plus negative 10, that's going to give me positive 1. So these are my values that I'm going to break w up into. So instead of writing just 1w, I'm going to write 11w minus 10w. So I'm going to get 2w squared plus 11w minus 10w minus 55. All right, now I'm going to use my grouping. So I'm going to have my 2w squared plus 11w in one group. Then I'm going to do plus my negative, and then I have my second group. So here I'm going to factor out a w. Okay, that's all I can factor out, w. And then I get 2w plus 11. And then here, what I'm going to factor out is negative 5. Okay, so if I factor out a negative 5, I have negative 5 times positive 2w, and then plus 11 again. And remember, we always want this and this to be the same, so I can finish my factoring. And I'm going to rewrite this as w minus 5, that quantity, times 2w plus 11. Okay? And this all equals 0. Okay? I could have rewritten the equals 0, but I was just factoring and kind of forgot to. That's okay. Anyway, now I just have to solve this using the zero product property. Well, w minus 5 is going to equal 0. And then 2w plus 11 is going to equal 0. What I'll have to do is add 5 here. I get w equals 5 as one of my values for the width. And I'm going to subtract 11. I get 2w equals negative 11 divide 2. Okay, notice I get a negative value for my width. So right away, I can reject this answer because I know it's not going to be useful for this problem. So I know that the width is going to be 5. So I found the width, but I want to go back and check to see what the question's actually asking. So if I go back all the way through our awesome work, it says, what is the width? So the only thing that they want is the width, which we found. Okay, and since this is in square miles, our width is going to be measured in miles. So the width is 5 miles. Okay, and then we can easily figure out that the length is going to be 11 miles there, but it doesn't ask that. So now that we've successfully solved for the width, now we're done.